Okay, so I believe we can start. So hello, everyone. Thank you very much for joining. First of all, I would like to apologize that I'm not speaking Romanian. Sorry for that. I do live in Czech Republic and I can offer you English and Czech language. And the percentage of people who can speak Czech in this call would be like really, really low. So that's why English it is. For sure, I do have my colleague Cosmin Vilku in here together with us, and Cosmin have the advantage that he is Romanian. So you can actually write your questions in Romanian into the Q&A. I will try my best to put them into the Google Translate to understand them, or I will ask Cosmin to basically translate it for me. But first of all, I would like to as well introduce myself. My name is Jan. I am Rynes. I am solutions architect at Infoblox. And I'm doing cybersecurity for 8 years now. Obviously, DNS and DNS security is something that I do like 5 years, but 2 years I'm actually at Infoblox. So I do present that I'm doing it for in full time for 2 years. And my topic today is how threat actors abuse DNS. And obviously, you guys would be like, oh, come on, what do you want with DNS? This is here with us since 1983. It works well. Why would we touch something that works? Because of this golden rule, do not touch what works. But basically, it's the most popular protocol on the internet. And many people forget about it. Even cybersecurity people and people who are really good at security, they do tend to forget this aging old basic protocol that we use every single day. We actually don't even usually know how many times a day. So this is something to talk about. And during my presentation, I would like to show you. Just really very briefly, because I am totally sure that you are not here to see slide like this, but really very briefly, Infoblox is an American company having 20 plus years experience with not only DNS, because we actually do have people who originated and started the DNS protocol itself, like Cricket Liu, and maybe no name to you. But this company started with the acronym of DDI. It's a shortcut for another shortcut of DNS, DHCP, and IP address management. And it's not us who's saying that, but independent companies like IDC and Gartner that are saying that we have roughly 50% of market share all over the globe. And we are doing this globally, so it's a US-based company, but global thing. So let's skip this slide rather fast, and let's focus on what we are here for today. Today, I would like to talk about the DNS protocol, obviously, but in general, we are talking in cybersecurity. And this European Union Agency for Cybersecurity have done this research and did the identification of top 15 threats in cyber world. And if you have a look at that, you will say, yeah, malware, ransomware, phishing, spam, threat, data leakage, data breaches, DDoSes, crypto mining, botnets. What might be the connection with me and DNS? Because I was looking at this and I was thinking, where actually I can find DNS being part of the attack in some bigger or smaller influence and counterpart during the attack. And I was going through every single one of them and basically looking, can I do something with DNS over there or not? And I've identified that out of this 15, just one is that will actually not, DNS will not help me at all. And that's physical manipulation, damage, or theft of the device itself. So sorry if somebody will smash your servers with a hammer, no DNS involved. But with the rest, there is a huge amount of security solutions out there. There is a huge amount that are more or less focused on different aspects and different cybersecurity part. And guess what? All of them basically work with TCP/IP networks. And with TCP/IP networks, you need IP addresses. If you don't have IP addresses and you have names, you need to have something to translate and correlate what IP address is what name. And voila, we have DNS almost everywhere where you look. Botnets, spam, phishing. Your mail servers simply need to know where to send the information. So with that, as I identified that the DNS is actually quite interesting topic, let's have a look how attackers see it. Because attackers tend to take the least non-intrusive paths. They usually tend to use what works well and nobody cares about. So in the background, in the past, we used to have malware that was like not deleting files. We used to have malware that was like changing icons on the desktop. Then we've got malware that was stealing information. Then we've got our malware that started to encrypt information. After that came malware that encrypts, steals, and encrypt information. Basically, attackers do involve, and as attackers involve, security companies involve. Right now, what I'm showing you on the screen is result of data breach. Data breach of a company called Lockheed Martin. They were victim of data breach, and they basically went to do forensic investigations. And after forensic investigation, they basically sat around and asked themselves what the attacker needed to do in order to be successful of breaching us. Because let's learn from our mistakes. Let's learn from what the attacker was capable of doing and we were not thinking about. Let's think as the attacker. And they've developed this framework. It's cyber kill chain with like 7 eased up steps, but really important steps of any attack. And they identified that. First of all, before I will jump into description what every step means, it's important to realize that we are not here talking about every single attacker. We are talking here about attackers that have set a goal, that have said, I want their data. So we are talking about advanced attackers who basically are doing something on professional level. I'm not talking here about niche attackers that are just ransomware creators, because these guys will most likely not follow these steps. They will follow just few of those steps. Because if you have somebody who creates ransomware, takes the ransomware and try to infect whomever will be infected, that's not advanced attacker. These attackers are like fast, wild, and loud. We are talking here about attackers that are totally opposite of that. We are talking about attacker that is silent, patient, and want the data and want to do something with it. So on the 7 steps, first of all, we've got reconnaissance. It actually doesn't matter if you would like to attack somebody with a stick in your hand or with the packets on over TCP/IP networks. First of all, what you do is a little bit of background check what your victim is capable of. Because if you run to somebody with a stick and he will have a machine gun, sorry, you will lose. And the same thing is here. The guys that are preparing attacks, they usually spend a huge amount of time on reconnaissance itself. They will collect whatever information they can. And it's not only about the systems, vulnerabilities, and other stuff. They are looking at the people, organization structures, whatever helps. And obviously with reconnaissance, you can do quite easy query on the DNS side to learn about your victim. What I mean is that obviously on DNS, you should never learn anything secret. And it's not secret. But let's have an example. In here, I've done just one simple query. I've selected something that will be close to you. So I've selected some news server in Romania. Sorry, I'm not a subscriber of that. I've just simply selected something that will be from your region. And I just asked one simple question. Give me your records. And the server did. So here we have a bunch of records. And you might think, okay, so this is nothing serious. This is normal information. And actually, we have to have this information inside the DNS, because if we would like other system to work, We have to have that. But think about the as the attacker. So the attacker sees, nice IP range, so nice tidy, so one place. Name servers, hey, AWS, oh, that's Amazon. So they are not hosting their own name servers, they are renting them. And it's here, whom to send some mails and so on, if you would like to. Mail, okay, MX records, Google. Okay, so they are heavily using Google. And TST records, they have site verification, they have another Google verification, and they have Facebook verification. So if I would be an attacker, I would know, okay, maybe I need to have a look if Google Mail, what protections they are using, if I would like to send them something and I would like not to be detected. So this is just really easy and simple stuff that is nothing that we can ditch. But what we can do is not answer to any, to make the life of the attacker a little bit harder, because there is no need in today's TCP/IP networks to get for one single request the same as I've got here. Just simply do not respond to that. It's a RFC, let's just implement it. So let's get back. That was the reconnaissance part. And after reconnaissance, the people that they will learn infrastructure and other stuff that the attacker will learn, they will realize what we can deliver, some kind of payload, some kind of backdoor, some kind of vulnerability. They will either buy it, develop it, create it, steal it, whatever. So that's the second step. Obviously, with the weaponization, there is nothing that we can do on the level of DNS. So that's why out of these 7 steps, this is the first one that misses an mention of DNS. After having something to deliver, we need to deliver it in some way. And obviously, as you see the icon by the delivery phase, there is a bomb with the ad in it, because most of attacks, like 90% of these advanced attacks, they usually start with email. And naturally, people, when they hear that the attacks are usually starting an email, they naturally think, okay, so we need to secure the email. And yeah, that's right, that you should have some email security, because most likely you don't want to have spam and attacks and whatever attachment in your email boxes, because it's most likely not good for you, but it's not the only way. And obviously, when people started to implement these security solutions, what was the reaction of the attacker? Okay, so they might have some mail security solution. Let's just deliver something that won't be detected as malicious part. Let's give them maybe stage number 0, just a simple downloader, the application that on its own is not malicious at all. So there is another thing. If you want to send email, what the mail server need to do? Well, he needs to know where the other email server is. So you see that the DNS is here to basically resolve that information, MX records. That's a DNS resolution. And if you have an email with a link inside the body and you click it, guess what? And again, it's DNS resolution. So it can actually even trigger infiltration over DNS. And I will show you real examples of that. The infiltration works just simply as a DNS protocol. The resolution process is I have some information and I want to know another piece of information. I have the name and I want to get an IP address. But let's think about it as attacker. I have data and I want another data. Obviously, there are rules that need to be followed, but that's the process. Data from point A, data from point B. Let's exchange that. So it's data exchange delivery solution. After delivery, the attacker needs to run it. And naturally, exploitation, exploits, protocol anomalies, and so on. And people start to think, okay, so if something will happen with my servers, I need to protect the servers. Maybe I need to protect the DNS server, so the DNS server is not capable of exfiltration or execution of some third-party code. But it's not only about the servers. DNS is a piece of software that is in every single machine in a modern operation system. You will find it in an iPhone, in Android, in Windows PC, in the servers, in macOS, basically everywhere where you need to talk with TCP/IP networks. And if the attacker will get actually hands on your authoritative server, in this case, somebody will leak information about credentials to Amazon, and they will change something in Amazon for the example that I've shown you previously. You can actually easily do attacks like man in the middle. But I would worry that every single machine can be something to run that code. After the execution, and these attackers are called like APTs, Advanced Persistent Threat. And the persistence is in the 5th stage. Obviously, again, no mentioning of DNS protocol itself, because it depends on the operation system that you are running. But the attacker most likely will not like to stay in the memory of the PC, I mean operational memory, because with a single restart, he will be gone. So he wants to stay hidden in the PC to run again and again and again, and ideally on the servers to stay forever. Because servers, you don't have to restart. You can stay with operational memory because servers do run 24/7. Now, after installation, the attackers either have two choices, either to have the malware to do its own thing as programmed and hope and pray, or they want to control and command it, command and control. So that's the 6th phase. And in the cyber kill chain, it's really important that it's on the 6th place. Yes, this is the most noisy part of any attack, but it's just all about hiding the command and control messages, because the attacker will need to communicate from infected endpoint towards to the internet where he lives. So it's just how well hidden this information can be. And guess what? I've seen command and control over email. I've seen command and control over file solutions like file synchronization solutions, HTTP, HTTPS, of course. But DNS is actually ideal, because have a look on your own firewalls and security protocols and security measures. Do you block DNS? Most likely the answer will be no. So DNS resolution, callbacks, and tunneling are actually perfect place where to hide such a communication. And it's ideal for it because you have a response, request, following by the response, command and control. And the 7th stage is usually too late, I would say. It's action of objectives. So the attacker have malware in it, can control it, and can do whatever he wanted to do in the first place. Steal data, encrypt data, start attacking somebody else. So this is cyber kill chain and the use of DNS with the attackers. So if you would like to imagine how it looks like if you would like to steal information, meaning DNS exfiltration, that can look like this. So first of all, you need to deliver something that will identify files, and then just use leaf of the land techniques to just take the file, break it to pieces, and piece by piece leak it through the DNS query. Because DNS have some rules, somehow have some limitations, and you need to follow the RFC of the DNS protocol. So every single red part in here, this and this and this, is just piece of your data. And it's just a matter of how to hide it so well that nobody will notice. If you do it like Wi-Fi to just burst the queries out, it will be an anomaly. So what you need to do, or the attacker, what they want to do, is just look like normal user is browsing the internet and drop after drop leaking the information. As you have a look on the picture, you have some kind of infected endpoint. Then we have got the DNS system. We usually have some kind of firewall in enterprise networks. And then we have got basically the internet with all the root servers and everything. And in this particular case, the attacker. And if you will say, but I would like to do it on a firewall. Well, you can try, but obviously it's depending on how you structure your protection and how you structure your networks. Because your endpoints usually ask with queries towards to the DNS system. And the DNS system have two choices, either know the answer or find the answer. So if it doesn't know the answer, it will do many connections towards to the internet until it will reach the authoritative server. And the authoritative server most likely will give them answer back. But this communication is typical. And on the firewall, what the firewall sees is not the client and his IP address. He will see DNS system IP address doing typical communication. So the firewall is not the greatest place to start to detect that. And as well, although today's firewall can do a huge amount of other useful security features, and the firewall still have its own place, it's simply limited to basically check every single piece one by one. But every single piece one by one will be valid query. So that's why the DNS system is actually quite a great place to do such a protection. And that's something that we focus at. So we do have algorithms, and I will not show you them today, but if you will be interested, let's get in touch later and we can have a talk about that. But this is where we do place our protection. Because firewall, it does have its own purpose and other work to do. DNS system, on the other hand, can be another layer in your protection. It doesn't messes with anything else. It doesn't messes with endpoints. It doesn't messes with the firewalls. It doesn't messes with the intrusion prevention system. It's adding another layer of security. So now, because that was just nice theory, let's have a look on something that have happened in the world already. Because I would like to support my claims with something that have actually happened. So as at a school, let's start with something quite simple. So this is an example of a malware that was living on payment terminals, so-called point-of-sale malware family called Alinatos. And this is actually an example of quite simple attacker. They just want to get payment information like number of credit card, validity, and CVC code. And how they done it is that they infected payment terminals that if you place the card to the terminal, it will do the money transaction. And as a bonus for the attacker, it creates query like this one. And this query, if you have a look at that, first, what is actually quite interesting on it is it's long query. It's not short, it's rather long. And the second thing, DNS in its RFC is not case sensitive. It doesn't matter if it's lowercase or uppercase. And here we have both. So therefore, this query actually was the technique how to exfiltrate the information. In fact, it was just base 64 encoded and XOR changed string. So this query is actually this line. So what you see is identification of the campaign, name of the PC, stage of the process itself, credit card number, validity of the credit card, and of course, CVC code. So if you would like to exfiltrate this information, just simply ask about this query. The answer will be a mixed domain, but you will get the information as an attacker. So on the internet, there were flying queries, and more than 10,000 of them between 2018 and January 2022. So this was example of quite niche attacker. Let's have a look on an attacker that is more advanced and more targeted, because this one was whoever pays. So this is advanced attacker, and as you can see on the right top of my slide is like one of the three, so one part out of 3 slides, because it's more advanced attacker, so I need more slides to describe it. It's Iranian group APT34, and here it's not just, this is just one identification. You might see another identification by different vendors and different threat researchers and so on. So Hell's Kitchen or Oil Rig is the same name. And they've decided to target Jordanian government. So what they have done is created email. And in here on, we have actually two emails. One is here, the second one is here with an attachment. But if you think back to the cyber kill chain, the reconnaissance was done really well because they were sending this email towards specific person. And because they were sending it to specific person, they most likely knew what the person will do with such an email. So they tried to play the game of, yeah, we are, they were pretending to be IT employee and they needed something for approval from this person that the person do that quite common. And in the first mail, they forgot to attach the email, attachment. So they've done it in a second mail. So naturally, you would think, okay, what's the big deal? We do have mail solutions. And this Jordanian government indeed had as well mail solution. But because the attacker have done so good work and good job on the reconnaissance phase, they knew how to avoid that. So let's have a look on it. The Excel sheet itself was relying that the user will enable VBA macros. Because they knew whom they are sending it, they knew that the person will click the enable VBA macros because most likely he's doing it all the time. But with the email security solutions, they actually did knew that this organization had email solution with a sandbox. And obviously, if you have a sandbox, you expect that this Excel sheet would pop up in the sandbox and detonate there. So how to avoid sandbox? In this particular case, the anti-sandbox evasion technique was just one of the macros have asked the PC, hey, do you have mouse? And that was it. Because show me sandbox that is a virtual machine and does have connected mouse. There are none. Or maybe now they might be to emulate that, yeah, we have mouse, but it's not only technique. You can have a look into temp folder if it's empty. You can have a look how many resources you have, who is manufacturer of the motherboard of the PC. And if you see VMware, and if you see that you have like 1 core of CPU and 1 gig of RAM, show me a machine in your network that have 1 CPU and 1 gig of RAM. So you can actually assume that you are in the sandbox and stop every other execution. So this sandbox have said, yeah, that file is okay. Let's deliver it to the person. So after another VBA macros were actually executed, every macro have reported its step via command and control over DNS. How they've done it is just simply put the QW, ID of the step, random number, and C2 domain name at the end, looking like this line in here, and just simply send this as a DNS query. So for the attacker, if we see query like this, he knew, okay, I have my macros that are running somewhere. The person opened the email, and the email was executed. How to create query like this? It's actually quite easy. And as I was looking at the presentations today, I've seen one technique, and basically that's a ping. If you take a ping and put like google.com, the ping will do DNS resolution on the background and present you with an IP address to do ICMP communications too. So in this particular case, ping via my function. And the rest of the Excel sheet was a base64 encoded backdoor that was creating a scheduled task to run every 4 hours for 20 days. The backdoor itself was .NET binary, so it was doing pre-coded PowerShell codes and command line commands to report the steps or download files from command and control. So here we have like command and control 3 examples in here and infiltration in here. Because the query itself was like this, hey, what should I do? Execute these steps if you are ID of 203. And that was actually it. It was ID of the host, the last octet. So for the malware, it was not an IP address. It was what to do. So some attackers do use fresh and new domain names. The advanced attackers usually age those domain names. So in this particular case, they did 3 domain names. So this Choepedia group, Uber Asia, and AzureDreamit.com. But these were like 2 to 3 months old with good reputation, with good categorization. So this is how they've leaked and attacked Jordanian government with quite big success, because detection of this was actually quite painful. Let's move back further because time is pressing us. I would like to show you multiple other examples because every example is focusing on a little bit different information. This example is called Invisimol. Currently, in the countries that this malware was present and was active, we do have a war, but let's not focus on that. Let's focus on what these attackers have done. They've realized that in army sector, in military sector, clients usually don't have access to the internet. So there is some kind of network segmentation. But if the network segmentation is not done thoroughly, you can still have a situation that this client will not be able to do any connections towards the internet on HTTP, HTTPS, and so on. But if they have access to the DNS server that does have access to the internet, this DNS server will act as a proxy. It's a default behavior. That is how DNS servers are behaving. And in this particular example, the attacker have managed to put some kind of downloader on the client. That was not harmful application on its own. It was just asking about DNS queries and receiving the answers. And with that, they actually did infiltrate the main malicious components towards the downloader, recreate them, and have the malware on them, even though they didn't have access to the internet. So this is example of such queries. And first of all, what will hit your eye is that they are same length. So the dots are on the same place. And obviously, they did not need to be there, because there is some space that would be empty and it's filled with A's. This is because some protection methods are using entropy, and this is how you avoid entropy. Again, attacker thinking about what they are doing, thinking, how can I be detected? Let's avoid that detection technique. Next example is ransomware. It's command and control of a ransomware called 5 Hands. The 5 Hands ransomware was using Sombrat vulnerability, and it was actually quite simple. The attacker had stolen credentials. So what they've done is open RDP connections toward their victims, place the credentials there, logged in, placed the ransomware on the machine, run it, and went away. If the credentials were not capable of using because they were expired, old, not working, they were targeting the infrastructure. So they targeted VPN concentrators. And what we do see here is a screenshot from our solution that's passive DNS detection. What it means is that this attack was not towards us or our customers. It was attack that was seen on the internet. So we have DNS resolutions that we've seen on the internet, and we don't know who, because DNS servers act as the proxies, so the information who is being lost. But we do see that there is one domain name that is ending on every single line of this traffic. And we see that there is some hexadecimal encoded information dot domain. So what this is actually the ransomware asking, I'm sitting here and here, what should I do? And the response back was looking like an IP address, as you would expect on DNS protocol. But if you look carefully, you will see that only 2 octets out of the 32-bit information is being used. So the attacker has actually used just half of that to basically respond back with information like sleep, do not encrypt. And when they got enough of those endpoints, they said, now let's go encrypt. So this is command and control over DNS. Quite recent one, B1PX or 20. and Linux backdoor using DNS tunneling. That this one is actually quite interesting. I have decided to show you this example on this conference as well, because when we were discussing with me and my colleagues, we were discussing what type of attack this is. We were in disagreement. And I've then said to my colleagues, hey guys, if we would be before COVID, I would agree with you. But we are after COVID and the world have changed. So I believe that this attack is actually towards to the enterprise businesses. It's not against individuals. The meaning for this claim was actually quite simple thought, because obviously this attacker getting system information, result of command line, other information, put it and compressed, encrypted, and pasted 64 encoded to put into DNS query and send it. The first priority for this query to go to the internet was TCP DNS query. And this was towards the public DNS, aka these. And you easily recognize that because that's Google. But in the enterprise, the best practice is having TCP UDP53 blocked a part of your local DNS server. So this priority number one should not be able to execute. With the TCP DNS query directly towards IP address of the command and control is the same story, should not be able to execute. Only the UDP DNS query in your environment, in a corporate environment, should be able to go. But when we have work from home, you usually don't have that. So if you are working from home, you are usually not blocking this. So that's why we've added this example towards to the our bench of examples that we are showing, because obviously the attacker was thinking about that as well. And they decided to have multiple ways how to communicate, because either attackers want to have high availability. So this was just a few examples, and I do have many more, but we don't have time and space to do it on a conference like this. So let's move on to a little bit different problems with DNS, because the weakest link in the chain of cybersecurity will be a user. And for several years, I was listening to people saying, we need to educate people, we need to educate users. And well, in my opinion, it's a good approach, but keep in mind that if you are opening an email, you are opening it with some kind of stage. So you are maybe tired after work, you are full of energy, and you will notice a huge amount of troubling things. But it's for the phishing attackers, it's just one person who will be just sleepy, tired, and clicking the wrong button and clicking the wrong link will be enough to infiltrate the company. And I would like to show you quite nice examples. And I would like to show you as a little bit of game. Certainly, normally I'm asking people to vote what PayPal is wrong and what PayPal is okay. We don't have space to that. So I will just simply continue that you will most likely identify this A as not being okay. So naturally, you would not click this link if it comes with an email. But which one would you click? And the simple answer is that you cannot see the difference. But for the DNS server, these are actually three different destinations. Simply as that, they are basically use of special characters. So this particular A's are special character, and this A is normal Latin character. So this is okay, and these are bad destinations. And as you can see, it's not easy to spot that. In the URL field of the browser, you should see the panic code. But how many people will copy the text, put it in the browser, to figure out what it actually says? If you would like to create some lookalikes, you have plenty of choices. As you can see in here, you can swap the TLD. That's the top layer domain. You can swap letters. You can double the letters. You can put dash or dot somewhere, and it will be different destination. We don't have to go that far away from this. I can show you example of other lookalike domain names, and it's so easy how to do it, because normal official domain is lowercase. The second one is as well lowercase, but with L in the front, not I. So try to do it when you have maybe small text. You will most likely do not spot it, because the lowercase L might look like a capital I. And if somebody will think, okay, so it's capital I because in the logo that's capital I, and now we actually have changed that, it's different story. It's different technique. So let's move on from these lookalike domain names, because to be honest, I've shown you the lookalike domain names on the examples on the beginning. The uberasia.com, well, there is no uberasia, but the domain is there. But other attackers are like using, for example, fresh and total new domain names. And as well, we've got botnets that are trying to avoid detections like reputation, or maybe using uncategorized domain names. So there are multiple other ways how attackers can avoid detection. First of all is like DGA. Most likely you will find it with botnets. And the DGA stands for Domain Generating Algorithms. And in here on the slide, I do show you multiple different malware families. And the number with the malware family is the number that domain generation algorithm have generated at that version. So all over, we are looking on almost 160 million unique domain names. I'm saying unique because only 17 out of almost 160 million were in a clash, some kind of duplicity, only 17. So this is actually giving us huge advantage, because these malware families, they are known, and they are creating domain names that are total nonsense.tld. Let's have an example. So just based on if your machine is asking about domain name like this one, you can actually with 100% probability say, okay, and if I see it in my network, I'm fighting with Game Over Zeus v2 malware family. Because this is a domain name that is typically generated by Game Over Zeus version 2. So this is the power of DNS. This is basically giving you quite early warning, because before any TCP or UDP session, you will have the DNS resolution happening. Only other way how not to have DNS resolution happening is hard coding IP addresses into the malware. But malware creators are not that much doing it, because if you will put IP address into the malware, and some kind of vendor will see that he will put this IP address to the blacklist, and the attacker is gone. And to change the IP address, it's much harder than change the domain name. So that's why they are actually using domain names and hiding the IP addresses of command and control servers. But as the time flows, attackers have realized that total nonsense like this, .tld, is actually quite easy to detect. So they've said, if they are detecting me based on this, I need to move on. So they did. And they've decided to, some of the malware families have decided to switch from the algorithms that are generating total nonsense to use like dictionary approach. Just simply take multiple dictionaries and put the words together to create generated domain name. And if you would have a look like facegone.net, would you say it's generated? Well, most likely no. But this does have some Achilles heel that we've learned how to deal with that, because we are doing DNS for more than 20 years from the beginning. And we've realized that those words will sooner or later start to repeat. So because the dictionaries are usually not endless. So therefore, we have learned how to detect such a thing. And we are doing it based on splitting different words into leveraging of TRF graphs, because this is how normal domain names are behaving on the internet. These tight chunks of black are the words that are repeatedly connecting to each other, combining them to have different results. So this is how DGA is working. And this is how we can actually detect that that domain name is generated by DGA. On the beginning of this chapter, I've said that it's as well new domain names. Because if you have phishing campaign that started with a stolen credit card, the attacker most likely don't have the luxury of time of having a domain name that was paid by a stolen credit card. So what they do is they register the domain name, that's this point of time, and start using it almost immediately, before the registrar will figure out that there is no payment. And with that, there are actually two really important steps in the timeline for the domain name. First is registration. Second is first use on the internet. And there are multiple different detection methods and organizations that are looking on those two first points of life of the domain name. But for us, the important one is this one. That's some kind of security vendor or somebody will say, hey guys, be aware, this is a phishing. But as you can see, there is a huge amount of time that the phishing will be effective. So how to avoid that is basically based on a registration date or based on first seen on the internet, start to block such a domain name. And you can actually avoid all of this. And later on, when somebody will tell you, hey, that was a phishing, you will say, okay, thank you, we've blocked it anyway. So this is the power of new domain name cardinalization. So you might think, okay, but Jan, hey, what if it's a valid domain name? But yeah, might be. But have a look on the internet and figure out if you would like, as an organization, to prepare some good product or service on the internet, what you do. First, you register the domain name because you don't want others to steal it for you. You want to be the first who registers that. Then you will start to develop, then you will do internal test, then you will do external test, and then you will place that service on the internet. That's several months, usually, not days. So if you have domain name that is 2 hours on the internet, is that the case? Most likely no. And to support my claim, I found out on a study on domain name system abuse that was done by European Commission on January 2022, is that they had a look on registered domains that was proven to be malicious, and they asked, so how many of those domain names were registered in purpose of doing harm, and how many of them were actually compromised domain names? So as you have a look on the slide, you clearly see that for spam and botnets, malware and phishing, there is more than half, and most of those domain names are actually registered in that purpose alone. So if you have domain name 2 hours on the internet, most likely it won't be good for you. So this is the again, why should we block such domain names? Although it might be a false positive, because if it's new, doesn't mean that it's bad. So you would naturally think, okay, so what we can do about that? And obviously, I can say we do have a solution for that. But I am not here to tell you about the solution today. That will be totally different discussion, maybe on some other day. I will just simply show you only this, that we do have approaches how to tackle all of these problems that I have shown you today. We do have solutions that are looking on multiple different aspects, algorithms that are showing and looking on zero-day threats, and we do support it with our own threat intelligence. But as I said, this would be totally different discussion, and today it's not a place to do it. So this is all from my side. Thank you very much. I hope that you found something interesting in my speech. And if you would have any questions, feel free to ask.
Thanks a lot. Let's see if there are any questions. It was nice that you covered multiple ATPs in great details. Pretty useful.
Yeah, we believe that sharing is caring. So those threats need to be understood. And I'm more than happy to share the information because only then we can move forward. And many people do not realize. And as I said, I know a lot of very talented and really good people inside cybersecurity that just simply are with like blindfolds over the eyes and saying DNS is nothing important. It just works, right?
Of course. And if something crashes, it's always DNS.
Yeah, for sure. So I don't see any questions, but any other feedback would be highly appreciated. So, but guys, thank you very much. I hope that the English was not something. Okay, I see question. Great talk. With this rise of use of DNS over the TLS and HTTPS, do these steps keep the same, or there are going to be other mitigation solutions in place? This is a good question. And I would answer that in several ways, because DNS is usually TCP UDP 53. But if you put DNS on HTTPS or TLS, it's still the same thing. You're just sending it to different destination. So it's not changing DNS at all. And it's just maybe putting more like blindfold over the DNS, because DNS is clear text, the typical DNS. And in my opinion, in DNS, there should never be anything secret. It's not secret. If you are going to the domain name is not secret. So why to encrypt that? You are just giving out or giving up on visibility. Because if you put it into the HTTPS or TLS, you need to get decrypt that in the first place to have the same visibility you used to have with the TCP UDP 53. But the biggest difference is where are you sending the query? Normally, you would like to send it towards to the DNS server that you have in your organization. But if your machine will send the DNS query towards to the public DNS, what will happen, and I will abuse this slide, this PC in here, your firewall in here, and you will have encrypted session like this. Well, do you see the pain? You are avoiding multiple layers because this session will be encrypted from this endpoint toward this resolver. And this is actually breaking the rule of like best practice, being able to see where your endpoints are going. So DNS over HTTPS is, in my opinion, a little bit different animal rather than TLS, because with TLS, you need to open port 853. With HTTPS, it's a GET request, totally the same thing as web pages and other multiple of solutions running on 443. So if this query would go to your controlled DNS server, you will have the visibility. And it actually can go over TLS or HTTPS. You can listen here. But the malware, if it will be configured to do like 8.8.8.8.443, well, then no DNS is in your premises is being used. So it's just moving the problem from something that you can control to the problem to the point what you don't control. And in my opinion, that's not okay. But it depends on the point of view. For user, might be good. For organization, if you are the chief security officer responsible for security of your company, you are losing visibility. But we can actually talk about this topic for quite some time, and we would need a little bit more time. Was this what was this answer like okay for the question, or maybe more information?
Jan, I was going to say, hey, let's talk tomorrow evening for a beer, but I just remember that you are not in Bucharest
Yes.
tomorrow evening for the beer. So
Thank you. That's a good point, Cosmin. I'm terribly sorry. I do live in Czech Republic, and I won't be able to go for the beer for you, but I will send Cosmin in my behalf.
Exactly, you can send some good beers from Czech Republic, please, not Staropramen, just good beers.
Okay.
I will switch for a second in Romanian, Jan. You're
Yes.
probably going to understand a bit. Dacă simțiți nevoia de mai mult de o oră de prezentare despre DNS Security, putem și ne dorim să facem întotdeauna cu clienții traininguri dedicate pe zona de DNS Security. E un training de 6 ore. E un training tehnic pe care își vrea să fie Ian, fie Piotr, celălalt colega nostru care e solution architect pe regiune. E vendor agnostic și vorbim mai mult decât a vorbit Ian astăzi despre tema de DNS Security. Luați legătura cu noi, să putem face fără probleme. Și dacă vă sperie 6 ore într-o zi, nu-i problemă, o putem face în 2 zile, câte 3 ore în fiecare zi. Sorry, Ian, I was telling them if they want to see more about DNS security and about the training that we can do on the topic.
Yes, for sure.